Ever since we first launched a camera into space back in the 1940s, we have captured millions of images of the solar system's planets, moons, comets, and asteroids. From the grainy but majestic first black and white photos of Earth's curvature to the magnificent high-resolution colour images of the distant icy world Pluto, we have been able to view the solar system in unimaginable ways. Only a select few people have looked back at the Earth from space firsthand, but it doesn't mean that we cannot also see it in all its glory. For more than 70 years, weather balloons, satellites, and eventually astronauts have been capturing thousands of incredible photographs of Earth, revealing its beauty, but also its fragility. This image reveals the Earth's sunlit side and was captured by NASA's EPIC camera, which is attached to the NOAA's Discover satellite. The EPIC camera snaps at least one picture every 2 hours from 1 million miles away in natural colour, allowing us to observe the Earth as it would look from our own eyes. In 2016, NASA assembled more than 3,000 of these breathtaking images into a time-lapse sequence that shows the Earth over the course of a year. You can see the ever-changing motion of white clouds that are partly shrouding the deserts and forests of the world, and of course, the distinct blues of our vast oceans. This is our planet, the Earth, in all its splendour. Until the mid-20th century, our neighbouring planet, Venus, was believed by many to have similar surface conditions to Earth. But when the Soviet Union sent their fleet of Venera probes plummeting through the planet's thick clouds, we finally got a glimpse of what Venus was really like. A hellscape of crushing pressures and devastating temperatures. This amazing photo was taken by the Soviet spacecraft Venera 13 in 1982 and was one of the first colour images ever taken from the surface of Venus. The probe was designed to last about half an hour while battling the blistering heat and intense atmospheric pressures, but the durable spacecraft ended up transmitting data for more than 2 hours after its landing. Although these images may not initially seem as stunning as those that we have seen from the surface of Mars, for example, when you think about the environmental conditions that the Venera probes had to withstand, they all of a sudden become a lot more incredible. For just over 10 years, NASA's Solar Dynamic Observatory, or SDO for short, has been observing the Sun and capturing hundreds of millions of high-resolution images. The SDO snaps a new image every 10 seconds in 10 different wavelengths, all from the orbit of Earth, allowing us to see our closest star like never before. This time-lapse captures the moment an enormous eruption occurred that produced a powerful solar flare and a dazzling magnetic display known as coronal rain. The footage is made up of thousands of photographs, and each second corresponds to around 6 minutes in real time. To show you the scale of this mighty solar storm, you can see the size of the Earth for comparison, providing us with an understanding of just how large and violent this event really was. In August 2014, the mysterious comet 67P Churyumov-Gerasimenko became a part of human history by becoming the first comet ever to be orbited and landed upon. The spacecraft that achieved this incredible rendezvous was the European Space Agency's Rosetta spacecraft and the onboard landing probe Philae. Before this groundbreaking mission, no one knew what comets looked like up close, but now we can analyse thousands of magnificent images. This black and white photo was taken when 67P Charumov-Gerasimenko was approaching the Sun and reveals a jet of ice erupting from its crumbling surface, like fireworks of frozen dust and gas. We were also treated to a short but spectacular close-up time-lapse that reveals the comet's surface. You can see what appears to be an icy, swirling atmosphere that is being illuminated by the Sun, with bright stars in the background moving vertically as the comet rotates. The probe is roughly 13 miles away from the surface during the time-lapse and covers a time period of around 25 minutes. The gas giant Jupiter is easily one of the most magnificent worlds in the solar system. Over the years it has been visited by numerous spacecraft, but none have captured its fierce beauty like NASA's Juno spacecraft. Juno has transmitted countless breathtaking photos of Jupiter, providing researchers and space enthusiasts with an unprecedented close-up look at the enormous planet, revealing its complex cloud formations like never before. Although it is common to see the heavily color-enhanced images of Jupiter that allow us to pick out stunning details in vivid blues, whites and oranges, in reality the giant planet is actually a lot more muted, as these true color images reveal. But nonetheless, you can still see the spectacular, chaotic bands of clouds rotating and twisting like cream swirling in a coffee. Orbiting Saturn is one of the solar system's strangest moons, the small, icy Enceladus. This mysterious moon has been photographed by passing spacecraft in the past, but it wasn't until Cassini arrived that we really got to see its frozen, tortured surface up close. This image was taken in August 2015 and dramatically displays Enceladus passing by part of Saturn's rings. You can also see the contrast between the moon's terrain. One side is covered in deep, ancient impact craters, while the other side is fairly smooth, indicating that a process is taking place that is eliminating craters. But this smooth, younger side isn't without its scars, because snaking northwards is an enormous fracture, providing a reminder as to how surprisingly geologically active Enceladus really is. This incredible time-lapse sequence is set over a time period of 14 hours and reveals the active moon erupting icy plumes into space, confirming that Enceladus must be hiding a subsurface global ocean. Although we already have access to millions of images of the solar system, we have only really explored a fraction of it. There are still many places to visit and many more worlds to explore further. But the images that we have collected certainly do stand as a reminder of how far we have already come, but also how far we still need to go. If you enjoyed this video and would like to see a part 2, then please tap the like button, subscribe, and let me know which images of the solar system you want to see next in the comment section below. Thank you all for watching, and I'll see you all in the next video.